Right, we are back with some quick math. We are going to do the Pythagorean proof. We're going to prove Pythagoras. Right, so what we're doing in this video is we want AB squared plus AC squared to equal to, let's just make that nice, to equal to BC squared. Right, so this is what we want to prove, and the triangle that is given over here, well, this triangle that you see that's given to you, it's given to you that this is 90, that is given to you that this is 90. Okay, so what we are supposed to see is that there are three triangles formed, right? So there is this triangle formed ABD. Let's see, there is ADC, right? And then there is the greater triangle, which is ABC. Right, so we have those three triangles that are formed. So in order for us to do this proof, what we are going to do is we're going to prove similarity between some of our triangles, right? So some of them, not all of them. Let's start by using the big one. So let's first mention which triangles we're working in. So we're going to say ABC in triangle ABC, and we are also working in triangle. Let's start with the one on the left hand side. So ABD. Okay, so we're working in those two triangles, the big one, and then also this one on our left hand side, right? And what we want to do is we want to prove those two triangles are similar. Now, when we do that statement there, we're just mentioning what we're working in. The order of the letters don't matter over here. The order of the letters will matter when we do our, when we write out our similarity, okay? So in those two triangles, the big one as well as this one over here, the first thing that I want us to note is the angle B. So let's say angle B is common. Angle B exists in both of those triangles, is common. All right. The next thing that we can notice is in ABC, this angle over here, angle A, is a 90 degrees. So we'll say angle A is 90. So angle A equals 90. How do you know this? Well, this is given. Okay, we can say ADB. This one's also 90. That's also given. Right, so therefore, angle A is equal to angle ADB. Right, you could have actually said these two statements in one, but that's also okay. So you have this angle, you have this angle, so you have two angles, and you know when we're proving similarity, right, you need three angles. But if you have two, you basically have three because of the interior angles of a triangle. So which angles have we not mentioned yet? We've not mentioned in the greater triangle, we've not mentioned angle C. So we'll now say angle C, and we'll say that that equals to, in the smaller triangle, we haven't mentioned angle BDA. So let's go say angle BAD. Okay, and they are equal to each other. Our reason for that is going to be interior angles of a triangle. All right, because of our three statements now, so we can say therefore triangle ABC is similar, so it's three vertical lines to triangle. Now the order matters, right? So in ABC, the big ABC, the A, which was your 90, was equal to the D. Then the B was common, so we'll write our B. And the C in your big triangle was equal to your A. So those are the letters, the order of the letters that you need to have. Your reason for your similarity was angle, angle, angle. Right? So now, because of our similarity, right? So because of this statement, there's certain ratios that we know. So let's write down our ratios. We're going to say that AB divided by BD. Right, so we said first and second is divided by first and second. That's what we said, and that is equal to last two, right? So BC over AB, which is equal to first and last. So AC over That's AC. I just want to write it a little bit nicer. AC over AD. Right. So now that you have this ratio, okay, and the reason we know this is because of our similarity. So just because it's right above, I'm not gonna write the reason over there. Once I have that, I'm gonna look for duplicates. Okay. So if I look at these, I see that here's AB here as well as here. So I'm gonna use these two parts and manipulate them to discover something, right? So I'm gonna take those two and I'm going to multiply both sides with AB. So I will end up with AB squared on my left hand side. And I'll multiply both sides with BD. So on my right hand side, I'm going to have BC multiplied by BD. Right? So this is the first statement that I need. Let's go back, look back at what we're trying to prove. We want AB squared, so we've proven AB squared. So we've got our first part. Okay. Now we're going to go back to our our triangles, and we're going to prove similarity in the different two triangles. Again, we're going to use the big one, and then we're going to use the one on the right hand side over there, which is ACD. Okay. And now we're going to prove those two. So let's start by saying, let's maybe do this. Let's see if we can angle up. Copy. Right. Paste. Okay. Right, great, that worked. So now we are going to find similarity again. So let's go in triangle. Again, the big one, ABC. Similar. Well, we don't know if it's similar yet. We are just in triangle. And the one on the right hand side, which is ACD. Okay, so we're just saying that those are the two triangles that we're working in. Right, so now what we can see is that in this one and this one, our angle C is common. All right, so let's go by C is common. Then we also know that our A is 90. And then we'll say, let's say A is 90, this is given. We'll say this angle over here, right? So we'll say ADC equals 90, or we can say 180 minus 90. And that is angles on a straight line. Right, therefore, angle A is now equal to ADC. Okay, right. So now we know because of 1, 2, we still need a third one, right? But because of 2, the third one is equal, right? So we'll say angle B, that's the angle missing in our in our big triangle. And in the small one, we've made reference to the D, we've made the reference to that D, we've made the reference to the C. So the one missing is the A, or rather DAC. DAC. So those are equal because of interior angles of your triangle. Right. Because of your three statements, you can say therefore triangle, it's again going to be ABC, is going to be similar to triangle. So A, which angle was equal to A? A in your big triangle was your 90, right? And D is our 90 in the small triangle. B was your DAC, so B is equal to A, and C was common. Okay, a reason for similarities, angle. Okay, again, because of your similarity, now there's certain ratios that you can find. So you'll say AB divided by AD. Right, so what was that? First and last? Well, first and second, right? And then we'll say this is equal to BC divided by AC. So second two. And then we'll also say AC, first and last, divided by DC or CD, first and last. And now we're going to look at these, and we're going to go look for duplicates. we see AC there and AC there, so these are duplicates. So we're going to use those two, and now we're going to multiply both sides with AC. So I'm going to end up with AC squared on my right hand side, and on my left hand side I have my BC multiplied by my CD. Now, yes, I did swap it around just so that I can have my AC on my left. Okay, but what I did was I manipulated this, multiplied both sides with AC, multiplied both sides with CD, and it ends up giving us this over here. Okay, so if we look back at what we're trying to prove, we have that part now. Okay, so we have this one. Let's maybe see if we can copy this, right? So we have these two, and with these two we are going to prove what AB plus AC squared, both of them squared, will equal to. So let's go with AC squared plus AB squared. Let's figure out what those are. So AC is BC times CD, and AB is BC times BD. Right, and now what you see, there's a common factor, so this is your common factor. We'll take out the common factor, so we'll say BC open bracket CD plus BD. Now when we look back at our picture, all right, so let's go back, our pictures over here. If we look at BD plus CD, BD plus CD, that makes up BC. So we're going to replace BC. We're going to replace this bracket with BC. Why? Because CD plus BD, back to our picture, CD plus BD ends up equaling BC, right? And that is equal to BC squared. Right, so what did we do? Let's just talk through the whole thing quickly. Okay, from the top. So we have this triangle over here, or this big triangle, which has two smaller triangles inside of it. We want to prove similarity between the big one and both small ones. So first ABC and then this one on that side, and then again ABC and this one on that side. Okay, we prove similarity by proving two angles. The third one is going to be equal because of interior angles of a triangle. Once you have your similarity generates your proportions. You use your proportions and you see the two that has duplicates, and you use that to manipulate to find AB squared, right? So either of these, you use the duplicate in your ratios to find AB squared and then again AC squared. Right. Similarly, you find the similarity. Where is it? Similarity of your big one ABC and your other small one. Again, find two angles. You have your third one because of interior angles of a triangle. Once you have your similarity, which is over here, you use your similarity to come up with your ratios. Once you have your ratios, you look for the duplicates. You manipulate that for the other part of your proof. Once you have those two pieces, right? So for us, it's over here. Once you have those two pieces, then you say AB squared and AC squared. You add those two together. Then you replace what AB and AC is with what we determined it to be. Then you took out a common factor. Then you knew that this inside the bracket is equal to your hypotenuse, and that ends up being that. So we can say therefore AC squared plus AB squared equals BC squared. And that's what we were trying to prove.